Welcome to another Tech Talk. My name is John Arrasjid. I'm vcdx #1, and I want to talk about something that's a little bit different. It's tied to products, but it's not about products. This title is called Workload Analytics Driving Infrastructure Design, and it's something related to what I'm working on in EMC's Office of the CTO at this point. It's my background. Some of you may know me as well. I won't keep this up too long. So this is the agenda I want to cover. I've only got 10 minutes, so if you want to hear a little bit more in depth, see me afterwards. But I want to cover what am I trying to solve and what are we trying to solve together. And that starts out with workload modeling, there's data collection, there's workload analytics, and there's infrastructure design. And I also want to leave you with some thoughts for the future and things to think about as you move forward. So what are we trying to solve? So we're looking at a new approach for infrastructure design. Many of you may be familiar with using Capacity Planner or other tools to gather information. You work through some analytics either manually or with other tools, but ultimately you're trying to come up with a solution that will meet what's needed today as well as in the future. How can something scale after the design has already been designed and deployed? So there are modeling and sizing tools that are out there. They take different approaches, and we want to think about different approaches as well that take this beyond what we've done in the past for both methodology and taxonomy for design. We need to understand dynamic service requirements, dynamic service capabilities. We also need to think about real or predicted results of applying a workload combination to a complex resource. We're talking about cloud and virtualization. We talk about converged infrastructure. We talk about a lot of different vendors, a lot of different products. We need to think about how do we look at real world data that has been collected historically, but what about these new Platform 3 workloads, cloud ready workloads, cloud scale workloads? How do we deal with new Internet of Things applications? Well, we can base them on things that have been done in the past with the traditional client server model. We also have to think about interoperability considerations. Things like several workloads, if they are put on the same platform, will they meet regulatory compliance guidelines? Will they meet some of the performance requirements? And how do we scale for the future? The last area I want to cover is on service requirements for existing and future workloads. So we need to think about not just one snapshot in time, we need to think about how can we compare what other people have gathered and collected, what other people have modeled as far as an infrastructure solution, as well as combinations of workloads. So first I want to do a quick run through of workload modeling is, and then I'll talk a little bit more about the analytics. So we're looking at high-level objectives here. What is the context that we're trying to understand about the workloads and the resources? This then drives the objectives and understanding what are the requirements, the constraints, and the target solution areas. Then we get into the workload definition. This is not specifically about metrics, it's about what does the workload do? What are the functional patterns? What are the design patterns that will apply when you actually do your your design and your implementation? And this gives you a lot more information that will then drive the last area where we're going into quantitative comprehension, understanding what are the metrics, what do they mean, how do they work together. If I have a heavy load on CPU and I have a lot of context switching, that's going to impact compute. But there may be ripple effects, like a domino effect of affecting other areas as well. And that's where we look at the workload metrics. So to get to this point, we need to start thinking about workload data collection. What are the tools that we use? So there are some tools within the Federation, there are some outside of the Federation, outside of Dell Technologies, I should start practicing that. And then there's tools that are open source or are free tools that you can use like SAR. So I've got a couple that are listed here. And we're using this to collect historical evidence. What has been done in the past based on a demand profile? What is the demand that will drive what we'll need to actually support the workload in the future, and we can scale based on that. One of the concepts that I like to look at is Virtustream's micro VM concept. Is anyone in the audience familiar with micro VMs? So there are other ways of looking at this, but it's one number that represents an atomic unit of all the resources that are used. So on a Sunday, we might have 1,000 micro VMs of use. That covers CPU, memory, disk, and networking. But then maybe on a Sunday, if that's the day that most of the people at work are off or your customers are off, we may see it drop down. Or we may see it go and spike during other time periods. But instead of looking at every little granular piece of detail, this gives us a best effort rough cut on what we believe the requirements are going to be for that particular workload. Now, when we look at the workload data, there are 4 different areas that we want to consider. The service requirements, what are the resources that we need, what are the specific technical capabilities and the configurations so that we can support the workload. There's the service capabilities. What does the vendor or the developer feel that you need to support those specific workloads? Then there's metrics. These are what we use to measure and do comparisons and actually do a rough cut and then eventually use some scientific approaches on what the final solution will be in support of the current and future technology. And then there's the context. So the context I mentioned earlier at the top level, but it can also be looked at the last stage. We can do some evaluations. If you are in a consulting group, you can start thinking about service requirements, capabilities, and metrics. And then for a specific customer, when you have that context, you can now fine-tune that implementation, that solution that you've created. So with workload analytics, we've got a couple of goals. We want to analyze historical data. We want to do some modeling. This is for the workloads and the resources, the relationships between each other, as well as with each other. So basically cross between workloads and resources and within each of those areas. And then we also have to identify anomalies in a design. To identify anomalies, these are things that we might be able to do manually. But on my last slide, I'll talk to you about what I think the future holds in this space. I'm going to say hi to the person who's watching on the RoboCam. Greetings. Tools using workload analytics. So there are some tools that are out there. I do work within a set of companies, so I'm listing some of those out, but there are many others out there as well. Exact, Virtustream's Advisor, and then Adaptivity has two tools, Planning Studio and Design Studio, that can also be used for analytics on the business needs, the technical needs, the operational needs, and then the final solution. And lastly, there's going to be customized scripting. In many cases, people start with the customized scripting, they figure out what they need to do, and then they decide what type of commercial tool they might want to add into that. So let's now take a look at infrastructure design. I've talked about the stuff that sets me up for this particular slide. There's historical modeling of data. This is where we have reference metrics. We look at analytics where we identify the inputs, run through some crunching of the information, the numbers, the metrics, and all of that, and then we come up with technical capabilities and that will support the actual final workloads. Now there's another thing that we have to do, taking this from another angle, and that is, what is the current problem statement? Let's get the context. What industry vertical? What is the business main objective, as well as all those sub-objectives? What are the business of making money or supporting things? You could be in a nonprofit and you have specific needs that will be different from a commercial company. Then we have another set of analytics that now takes the other analytics that have been done, and then with that context, with the current problem statement, refine those requirements, refine the analytics, and then we feed that into a modeling engine for design, and ultimately we get a recommended solution that has both that logical and physical design characteristics. So I had a hard time thinking about fitting within the 10 minutes, so I'm going to be talking a little bit more after this if you have questions, but I wanted you to leave everybody with something to think about. As we deal with more workloads, we deal with the Internet of Things, so going from maybe hundreds or thousands of apps to millions of apps. And who knows, in the near future, we might see billions of apps out there. Refrigerators. I have a Nest thermometer. I have a number of different types of lights that are on the internet. We have to think about security. We have to think about accessibility and things like that. One of the things that we can do with large amounts of data, including very old data and very new data, is using big data analytics and machine learning to move things forward. And this is an area that I'm working on in EMC's Office of the CTO. I may not be able to go into a lot of the detail, but I wanted to get you thinking about this. As you look at analytic tools, think about how they deal with big data and how they think about machine learning, so that what you have today is future-proofed, But of course, things change. And as you get to the future, how does that evolve? The design that you've created, the operational, the technical aspects, and so on. So what I'm going to leave you with is, oh, sorry, a blank screen. My apologies. What I'm going to leave you with is something that I think is going to be very important. Take what you're doing today as an admin, as an architect, or other roles that you have that it's tied to IT. Look at the data you have, look at the tools that you're using, and start thinking about how you might bring in machine learning and big data analytics. These are things that are coming. There are very many vendors that are working in this space, and it's something that is going to be very valuable going forward, so that we can take things like DRS or other types of rebalancing clustering tools and be even smarter. It's already very smart, but I think this is going to be the next stage. That's what I see as the future. I'm going to leave it with that, but I'm going to offer for those that are still here an opportunity to win a copy of the new infrastructure design book. We're going to do another tech talk tomorrow. Mark Gabrielski, myself, and Chris McCain. I also have Damon Baer and Brandon Hahn who will be around also. And we'll also be doing a vBrownbag in the near future about the new books that are coming out in the series. So see me afterwards if you're interested in the raffle for the new hardcover book. Okay. Thank you very much.